All right. I will hand it over to Mark, and he will be talking us through the presentation.
Awesome. Thank you. Thank you, Rob. All right. So first off, I will be on my phone today. I'm taking this webinar from work, and my work computer is a little tied up running some programs right now. So it's probably best I just work from my phone. So if I have technical difficulties, then you know why. So welcome to the FNL25 RockSim webinar. It'll be hosted by myself, Frank, and Brittany. Enter your Zoom. Sorry, as you enter the Zoom, please put your name and your school in the chat, please, for our attendance records. And as Rob mentioned, we will be recording. So overview, what are we talking about today? This is all new for teams or students who've attended last year or previous years. This is kind of tailored specifically to, what we see, what we kind of see in your RockSims as you're submitting them at the different milestones. We're going to focus on some of the, just giving an overview. What is RockSim? So there may be some new people on the call or new teams. I've never known RockSim. But it's not a basic webinar. So for that basic stuff, we'll kind of point you to some RockSim resources to give you the basic knowledge of RockSim. So you're going to need to go on your own and do some internet sleuthing or check out our FNL website to get the basic ins and outs of RockSim. I'll talk a bit about the rocket files, how we get a rocket file into RockSim. We'll do a quick, loading the file, making some minor tweaks, the things you guys need to do to the file before you run it. Verifying the file's, correct and going to work properly. We'll talk about recovery, parachutes, modifications you need to do. We'll talk about mass objects, which represent your challenges every year. Something not typically done in RockSim. You may not find any, tutorials or guidance outside of FNL that talks about challenge components in RockSim. We'll talk about the motor, how to find those and load them, and then do some flight simulations and how to get the data out of RockSim that you need for your fly sheets. And then finally, we'll review some common errors. Next. All right, so what is RockSim? So just a screenshot from their website. I'm not going to read that. It's basically just a computer program, right? You guys are all in school and college. We have programs all the time to do all kinds of stuff, whether it's Microsoft Word or, whether they're gaming programs, right? RockSim's meant to kind of allow you to simulate, high-powered rocket flights in that regime. And it helps you, it's a tool to help you make design selections before you just go out and buy components. Because if you go buy a bunch of components and you put them all together, you don't know how they're going to perform. And it's the same thing in engineering, right? Like here at Blue Origin, we simulate a lot before we go and buy the components. We don't just randomly say, hey, we like this look, we like that look, we're going to put them all together. You don't know how they're going to perform. You got to understand your performance first before you go out and buy all these components. So first station launch requires all teams to acquire and use RockSim. That's a requirement. I believe it's in your acceptance letters. I know there's other programs out there, Open Rocket, whatnot. Feel free to use those if you want, but whenever you're submitting files to FNL, they need to be in the .rkt format. And this is just basically for consistency. We need all teams to be able to compare apples to apples when you're submitting. So we on our end, we need to select one of the programs so we can have that apples to apples comparison. And we selected RockSim as that program. We do give you sufficient funds in your grant to go and purchase RockSim. In your acceptance letter, you do get a heavy discount on the RockSim licenses. I think they're like $20 a license. So with a $4,000 grant, spending allocating $100 for simulation licenses shouldn't be a problem to use RockSim. Next. All right, so we talked about some resources for you, especially if you're new to RockSim. Even if you're a veteran to RockSim, maybe go look at these resources and maybe you can catch some information that you never caught before, learn something new. So the first resource we're going to point you at is the Advisor Handbook, Appendix D3. So I think there's about 4 or 5 pages It kind of talks about, again, about simulations, the importance of simulations when you're designing your rocket, the goals of the simulations. There's a little bit of tips in there about procurement, like where you go, which website you go to, and how you enter your FNL code to get that discount. There's some information there. It talks about additional design files. So if you can't find your rocket kit in the RockSim library, that information it's provided in the handbook appendix. And then it also talks about additional motor files. So again, if you can't find the motor that we've allocated for that year, you want to run a motor that's different than the ones we've given you, and they're not in the RockSim library, there's a way to import that. You can learn that by reviewing the handbook information. Another FNL resource, of course, we put some time and effort into the rocket instructional videos. So there's a link there at the bottom of the screen. I don't know if Rob can post that in the chat for you guys, or if you guys can write that down if you haven't been to the rocket instructional videos before. There's a series of 5 videos. There's one specifically on FNL RockSim. I think they're about 10-minute videos. They're not too long, kind of just a quick summary. It may kind of, follow the same flow as the advisor handbook. It's going to talk about, what is it? How do I download it? How do I buy it? And kind of what it's used for. And it's going to walk through the same stuff that we may cover here on on this webinar. Next. Some more resources. So these aren't FNL resources. Now these are Apogee Components website, which is the maker and distributor of RockSim. So we kind of gather these together, and we want you to go check out the vendor's website as well. So there's some RockSim overview, various topics. So at that link there, Apogee Rockets. Up to Rob if he wants to put these in the chat. You could just Google them as well, right? Apogee Rockets, Apogee Components. I'm sure if you've been to the website to download the software, you've kind of poked around in there as well. There's some RockSim video tutorials. There's a page there as well, and it has 35 topics. So we'll see on the next page, actually. We'll give it a minute, but we'll see some of those topics. There's also newsletter articles. They have Apogee Rockets has a online newsletter called Peak of Flight, and I believe there's over 100 topics, 100 articles about RockSim. So if you're looking, how do I simulate a hatch in the side of the rocket? How do I simulate perturbance into the airstream? How do I simulate a camera cover, right? There's a lot more resources on the vendor website than we can give you here from FNL. So go check those out. And then, of course, the RockSim program guide, right? So, just like with any program or anything you purchase, right, it usually comes with a manual that kind of describes, all the features, ins and outs. So be sure to go check those out. Next. And then just as we mentioned, here's some of the topics. So the screen on the right, highlights some of the video tutorials. That is much too small on my phone to read out, but hopefully you can read them on your screen, or you just go to the link and you can read them yourself. And then the one on the left there just has some articles about kind of a page about, some highlights of why and what and how and who, the benefits of RockSim. All right, moving right along, RockSim rocket files. So another 2 methods of beginning your simulations. We prefer you download your basic rocket file of the kit you selected. Again, a lot of teams are using the COTS kits. I know for Moon, you're required to use a COTS kit. For Mars, some of the Mars teams aren't using a COTS kit, or they may be kind of modifying or fabricating off of a COTS kit. But by the time you get to the Mars level, a lot of those teams and students, you're very familiar with the RockSim and things like that. So here we'll talk about, just preferred, we want you to use a COTS kit. And if you do use a COTS kit, as you're researching those kits online, most manufacturers will provide a basic RockSim file. We'll see an image of that in the next couple slides here. If there is no file on the vendor's website, however, you can still search the internet for a basic RockSim file. There's a link there. Rob can share that. Rocket Reviews has, I don't know how many. I think there was like 1,000 or 2,000 rockets in that RockSim library. But just keep in mind, it's a user database, right? So it's not just going to be like a basic stock rocket. It's going to be somebody's rocket that they worked on maybe 10 years ago. They made modifications to it, right? So just tread carefully when you're going to that rocketry reviews website, right? Make sure you understand what rocket you're looking for and which one you're using. So it all, it's preferred that you go to the vendor website. You're going to get a basic stock rocket that represents what you buy. If not, and you go to the user library, just be careful what's in it and make sure you understand it. And we'll talk about verifying the file to make sure it's verifying the rocket to make sure it's up to par. And then also too, just keep in mind some of the rockets are very basic. So don't think that, hey, I went to this website, I'm going to buy, Rocket X. It's going to give me the RockSim and it's all complete. Usually the RockSim files are very basic. They're not complete. It's up to you to kind of make sure you add all the little detailed components because everyone as you buy and everyone as buys them, everyone's going to have different components, right? So you and the next guy beside you may have a different parachute, or you decide to have different eye bolts, or you decide you're flying bigger altimeters or more batteries or whatever it is, right? Or even your finish, for example, you may decide to spend $1,000 on polishing the surface, and the guy beside you doesn't. So these are the things you need to consider and modify in RockSim as well as you assemble and make those component selections. The second method to beginning your simulations, you can also just build the rocket from scratch, like using kit components in RockSim. So that's just basically taking a blank screen in RockSim, and there's a way you can just bring in tube, bring in nose cone, bring in fin, and kind of piece the parts together that way as well. That's not super preferred. It's interesting because you get to learn a little bit more about RockSim ins and outs. But we just want you to kind of, because you're building a COTS kit, just grab the RockSim file off the vendor's website and start there. Next. All right, so just some examples of a vendor website. That's an Iris 4, I think it is. 4 would represent the diameter, and the red box just kind of highlights, it's a screenshot of a website, it's a vendor. So you'll see, you click on that red box there, and you'd get a download of a .rkt file representing that Iris rocket. Notice there's some specs there on the screen as well. It talks about diameter, weight, thickness, material. Those are things that even once you import the rocket into RockSim, go back to the vendor website and make sure things kind of match up. Make sure that the simulation file, if it's fiberglass, that the actual rocket is fiberglass, right? There's no guarantee, there's no promise that it's going to be the same. You need to verify that for yourself. Next. And then similarly, if you're going to the user database, the Rocket Reviews library, it's in the lower right there. And again, there's the link there to get to that RockSim library. You can search, whatever it is, Lock Precision or Wildman, whatever manufacturer you want, whatever kit you want. And then you'll open the screen to the one on the right. And again, you can see the red box highlighted. That's where you click and it'll download a .rkt file. So very similar to the vendor manufacturer one, but this one will have a little bit more details or modifications to it that the user made before they launched their rocket. So again, it's up to you to verify, is this what I purchased? Or is this what's arriving when it shows up? Or do I need to change this, right? All right, so moving on to running simulations. Yeah, now you have a file, you've gone and you've done your research and you've got your .rkt file, whatever, so for Rocket X, right? So you're gonna open RockSim, you've done all the steps, you've downloaded it, you've got your license, and you're gonna load the file. And we'll just show you here. This is the basic user interface. Just a disclaimer or note, this is version 10, this is V10. They do have a version 11, V11. We'll talk a little bit about the differences between V10 and V11. If you're new to RockSim and you just got it this year, you probably have the V11. Some teams from last year may have the V10 still. I'm still running the V10. I've had RockSim for a while. I'm going to wait to upgrade to V11 for a while here probably. But so the rest of this webinar you'll see is the V10, but very similar to V11. So you got your main user interface. You're going to go next. You're going to go File. You're going to Open. Highlighted in the left image, the upper right. And when you go File, Open, RockSim is going to open a database of, standard rocket files. So you may have your kit or your .rkt file maybe in the database already. So you don't need to go to the website, or you don't need to go to the user library. Um, so, poke around in there, get used to some of those manufacturers, those rocket files. You may find your rockets in there already, and you can open and download it. You may also get ideas like maybe I need to check out these vendors on the website, right? Maybe there's again, I can't read that tiny text from my phone, but the first one, for example, you would say, hey, what do these rockets look like? Where is this vendor located? Maybe they're in your city, right? And maybe it's more convenient to buy a rocket that's, from a vendor in your city. You could just go to that store and look at their selection, and away you go. If not, of course, like any other file, if you can't find your database, you'll just go and search in the windows for where you saved your .rkt file. Next. All right, so you've opened your .rkt file and you've got your rocket now. Rocket X is now on the screen. So the first thing you'll see is the rocket design attributes. I need to not mislead you in this. Yes, rocket design attributes. So you'll notice the text box, the red box, kind of highlights some parameters there. And we want you to make sure that you're using those parameters correctly. So one of the ones is showing CP location. There's a drop down, and the drop down is not shown on the screen, but we want you to use the Barrowman stability equations. So make sure if you guys have your simulations open beside you right now, that you go in there and set to the Barrowman stability equations. Make sure you have the number of stages set to single stage. It should by default just be single stage. That's the only, you guys aren't launching dual stage ever in FNL. And then make sure the static margin reference is set to the nose cone base diameter. And then of course, above it there, your rocket name, you can change your name to whatever you want. User reference diameter doesn't matter. And then the parameters on the right side of the screen just control the size of the icons in the image that's at the bottom of the screen. So if you can't see the CG or the CP, or you can't see those letters and they're kind of small, just increase the number on the left side of the box, and it'll increase the size of those images, allow you to read your icons a little bit better in the bottom image.
The default is usually pretty small, so you got to make it bigger by like 2.3 on each box to make those parachute, mass, and center of gravity and center of pressure bigger and more notable. It does enhance it pretty nice.
All right, next. So then once you've loaded your rocket, right, again, maybe it's rocket X from, website Y. I don't know what this rocket is. Is this rocket going to be accurate? We're looking for kind of some basic components to make sure it's a dual deploy rocket. So we'll start from the left side of the image, right? So you got to make sure it's got a nose cone, it's got the pointy end on it. And even a nose cone shoulder is important. See the rectangle there, kind of between the nose cone and the next booster tube. Those shoulders are important to rocketry, whether it's physically, having that shoulder in the rocket, or just in the simulation. You need to have your shoulders because that's mass that needs to be accounted for. So make sure those shoulders are accounted for in your rockets. There's various different ways in the simulation to make the nose cone shoulders. The next section behind it is your sustainer tube. It's known as, and that's where your main parachute will live. So you see the big rectangle that says P in it. That's main parachute. So that's kind of just sitting under the nose cone. Next, you'll find your avionics bay and your coupler. Kind of the two terms are used. The structure itself. I refer to the structure as the coupler. That's the tube that the other two tubes sit around on the outside. That's what's known. It's coupling the two tubes together, right? But inside of that coupler is usually where you put your avionics. You're going to put a lot of electronics, however many you can, or whatever you need to require in there. That's why it's called a coupler avionics bay. Notice it also has a switch band. That's a common mistake a lot of people make, or a lot of simulations come with, and they don't have a switch band. So make sure you're simulating that because that represents the actual structure that you're going to need. And that switch band is important because you're going to need to put your switches there. As the name of the switch bands implies. You also need to have your vent holes in that switch band. So make sure your switch band is visible and represented in your rocket simulation. The next section behind that is the booster and booster drogue parachute. So you see the little square with the little P in it. That's your drogue parachute, and your drogue parachute sits in the booster tube. It's in the smaller section there as well. And then notice you have centering rings, and of course you have fins, right? All your rockets should have fins in their simulations. You're gonna have a tough time flying if you don't have fins on your rocket. Your tube's just gonna come off and tumble in the air and not know where to go. So that's kind of the basics of a dual deploy rocket as far as the structures go. And we'll talk a bit more here in the details as we go. All right, so now verifying the rocket again. So that's the visual inspection, right? So you're going to look at the image and kind of make sure it has all those components. Another way to verify your rocket is look in the tree. It's what's called the component tree, right? So that's kind of the upper section of the user interface, and it kind of lists the parts in order. So note the sequential order, right? Nose cones first, and then the next section is called sustainer, body tube, and then switchband body tube, and then booster body tube, right? So notice the sequence is kind of important. I like my trees to kind of be in a spatial order. So as the components go from left to right, I'm going to try and list my components in the tree from top to bottom. And you can easily move components in the tree. There's a way I think you highlight it and you can move up or move down to make sure your components are in a nice visual order, sequential order. Also notice the naming convention. I'm not just, they're not just called body tube, body tube, body tube, right? You're putting names on them to help better identify them. Sustainer, booster. Even on the right image there's an aft center ring and a mid centering ring, right? So revising those naming conventions, because when you download the file, it may just say center ring, center ring, center ring. And then when we're having a conversation or if you need feedback, I'm going to say, hey, that mid center ring needs to be changed or improved. And you're not going to know which one it is, right? Even amongst teammates, right? You could say, hey, we need to change the body tube. Unless you know which tube it is in the simulation, right? They're going to get the wrong body tube. So make sure to update your naming conventions in your component tree. And then notice also the grouping of parts. So some of the parts are collapsible, they're ownable, right? Especially like the coupler in the avionics bay, you can put a bunch of parts as sub-assemblies. And it's the same thing in engineering world. When we're looking at CAD models on the New Shepard rocket, for example, a lot of, there's sub-assemblies that kind of go together and they all collapsible into each other. So make sure you clean up your tree and verify you understand what all of those parts are and what each of those parts does and that they're sitting in the right place. And that those are the parts that are going to arrive when your rocket shows up. So do that comparison, right? When it shows up, modify your simulation to represent what your actual rocket is. Next.
Especially when you're adding mass, always label what that mass is, not just saying mass. Recovery harness, avionics, weight difference.
Yeah, we'll talk about mass objects here in a bit. And we'll see what Frank's talking about as far as the naming conventions for masses. All right, so one of the things you'll probably need to do, so say your rocket checks out, you got all the parts, you got all the components, the tree looks, fairly decent. You're kind of like, hey, what do I got to do next? One of the main things you're going to do is you're going to modify your recovery, your parachutes. What you usually buy from the vendor as far as the parachutes that come with it, if it comes with them at all. Sometimes some vendors don't give you a parachute. You got to go out and buy your own. Usually they're not sufficient for the flight because as part of your challenge, you're modifying the rocket itself. You may add, say the parachute that they give you from the vendor is sized for a 10-pound rocket, which is fine and all until you go and add 2 more pounds of electronics challenge, components. Now that parachute that you got with the rocket's no longer sufficient to meet the safety requirements. Thanks, Rob. So you're going to go in and kind of as you evolve at each milestone and as things change, you're going to go in and change those parachutes. So the way you do it is you'll click on the main parachute. Hopefully your model has a parachute already. So you're going to right click on that and you're going to go edit like the box shows there in the upper right. So notice, like I previously mentioned, your rocket needs to have 2 parachutes, a drogue and a main. We'll just talk about changing one parachute. We're going to change the main parachute. Next. So when you click on the edit box, you're going to open the dialog box on the left, and it's going to kind of show your parachute selection. It's the general parachute, the general parachute. There are multiple tabs across the top there. Notice in the general, it's a 60-inch parachute, the diameter, right? And we ask you for that in the fly sheet, every kind of milestone report, and say, hey, what's the size of your parachute? You're going to say it's a 60-inch parachute. One other important parameter you're going to look at here in this dialog box, it gives you the descent rate. I believe the descent rate says 26 feet per second, which exceeds our requirement. If you look at the handbooks, the descent rate requirements are 20 feet per second. So in the note there, of course, it says our rate exceeds the requirement. So what do, right? If you're descending too fast, you need to pick a bigger parachute. So to select a larger parachute, you're going to use the RockSim database. So the image on the right is the database, which is the same tab, the next tab over on the top. You're going to click database, and you go in and choose from database. And then basically the RockSim database opens and it gives you a selection of, 20 or 30 parachutes from, 6 different manufacturers. So you're going to look for something that's bigger than the 60, whatever that is, a 72, an 85, and maybe you'll kind of select that. And then the dialog box on the left will update with those parameters. So just one other note, you're not trying to change the numbers in the left dialog box. All you're doing is the left dialog box is just telling you those parameters from the database. So always just select the database and trust RockSim to populate those numbers and values in the left database, the left dialog box properly. If you just go and alter numbers, that parachute doesn't exist. Like you can't control what the coefficient of drag of a parachute is. You can't change the length of the shock cords unless you're the manufacturer. So all you're really doing is you're allowing RockSim to kind of, populate those cells with those parameters from that manufacturer. Next. And then just one other final slide on the recovery. So again, we highlighted the main parachute. You can see it's in the sustainer section there on the left side of the rocket. So your parachutes should be configured like that. All rockets are configured with the main to the left, drogue to the right, with the aft on the right. Also note, so one other thing to note is that the rectangle actually represents the volume that your parachute is expected to occupy. So we've had times or teams in the past where they select a parachute and the parachute shows up and they can't roll it small enough to fit in the tube, or they've managed to either shorten the tube somehow where the parachute doesn't fit. So make sure you understand that, as you change that parachute selection, you need a certain amount of volume. And parachute manufacturers will have different volumes. Some of them are standard, some of them are really slim. You pay a little bit more for a finer material, less volume, right? So make sure that you understand the volume that your parachute occupies. Also on the slide, I want you to notice that the position of the parachutes are aft in their respective tubes. So this is where they'll sit when the rocket's vertical. So don't, in simulation, you can move those parachutes around. Always try and keep them on the aft side of the rocket, because when the rocket's vertical, right, all that stuff that's free floating is now going to sit down at the bottom. And that'll affect your CG, which is important for your stability. So we want you to report out the accurate stability. So everything needs to be aft in the rocket where possible. Next. All right, so challenge mass. So again, for this year's challenge Moon Mars, we want you guys to incorporate some sensors and microcontrollers, maybe some other hardware. What you're going to do is you're going to click on the owning object. So if you want to put them in the avionics bay, you're going to right click on avionics bay, and then you're going to go add new component, mass object, shown in the right. And then also notice at the bottom of the screen, when you click on the owning object, it highlights that object. My couplers are green, so I also use color coding in my visuals as well. So that's a good trick or a good tip to use as well. So you can go in and change the components, right? You can have your external tubes blue, internal tubes green. You could have nose cones and fins orange or whatever color it is, right? You use the colors to help you differentiate components within the 2D visual. So we're going to add a mass object next, representing the challenge payloads. All right, so your mass object dialog box is going to open up here on the left. And then you're going to put in whatever your estimated, you're going to manually input the mass and location of your mass object and minding the units. So notice you can change the units. It's in ounces. I think I put in 16 ounces or 14 ounces or something. And that's maybe from the website. I'm going to go and look at the website, and maybe it says Arduino Uno is 4 ounces, but maybe a LiPo battery is 3 ounces, and then some screws and hardware to hold everything down is another ounce, right? So I'm going to try and determine initially what all this stuff weighs and put that in the rocket. One thing you'll notice too, the box on the right may actually open when you add a mass object. It points you to the database right off the bat. But you can close this for your challenge payloads because it's not going to have challenge payload listed in the database, right? This is one of the unique things to FNL that we mentioned. And we'll talk about the database mass objects here in a second. Next. So you're going to kind of repeat this for all of your challenge objects. So you can see also too in the 2D visual, I put a sensor and a controller right where the red square is. So it's going to sit inside that avionics bay. If I'm a Mars team, I need 4 more of them. I need 5 of these objects sitting somewhere in the rocket, right? If I'm a Moon team, I need 2 of them. So I'm going to pick, well, where do I need to add them, right? You're going to move them around. And it's listed as an M inside the visual. M tells you mass object. Next. And then you also need to add mass objects for the general components. So general components are anything like eye bolts, screws, batteries, altimeters, GPS, I don't know, shock cords, any of the hardware that goes in the rocket. Now, this is a good point where now these will probably be listed in the database. So again, when you go add mass object, like we saw on the previous screen, it opens the database. You can see I highlighted an altimeter, I believe. So maybe that's the altimeter I want to put in the rocket. So I'm going to click on that altimeter, and I'm going to move it to where I want it in the rocket. And keep in mind, you're going to add a number of these mass components or mass objects over the course of your design. So at PDR, we want to see a few more mass objects in your rocket. At CDR, we want to see 99% of your mass objects in the rocket. If you start adding a lot more mass after CDR, you're going to find that your altitude comes down, because if you make your motor selection at CDR and you start adding mass after CDR, you're no longer going to hit your target altitudes. So incremental approach. Next slide. All right, preparing for launch. So now you got the parachutes all selected. You got a couple of mass objects in there. You got an altimeter. You're going to prepare for launch. So again, simulations on the main screen. You're going to click simulation, prepare for launch. It's going to pop open the dialog box on the right screen. You're going to go into, is that flight? Is that engine? Mount, engine, detail? Sorry, I don't have them memorized. I know where they are. It says engines, right? On the upper right of that, upper left of that screen. And down in the bottom, it says choose engine. So that's what you're going to click. Choose engine. Next. And you go into choose engine. It's going to show you the engine selection. Again, there's another database in RockSim that has all the engines, right, from all the manufacturers. So there's more manufacturers than Aerotech. Aerotech's kind of the default one we use with FNL, but there's Cicerone and a few others, Loki, and a few other manufacturers that you'll find in the engine database. Of course, the handbook Appendix A1 has your challenge motors. So you're going to find or pick those challenge motors, right? Go into the rocket, pick K500 or whatever it is, and click select or load, and that'll load your motor. If a motor is not found, so again, not every motor is found in the database. There's a way to import motors. You can see the resources if you want to do that. Apogee provides some methods, and I think the handbook and our video may also describe some methods. You can also find complete motor data at thrustcurve.com. So we can drop that link, Rob. So if you're looking for thrust curves, or in a lot of the reports, for example, you may say, hey, we're looking at this motor and it weighs this much, and here's the casing, and here's the cost, and you can get all that data from ThrustCurve. Next. All right, so run the simulation. You got a motor now, you got some parachutes, you're good to go. Few ways to run, always multiple ways to do something in any program, right? In the left-hand screen, you can just click the little arrow with the little rocket with the motor burning off of it. That's how you launch. From the other window on the right, when you're in the setting up your simulation parameters, you could just click launch down at the bottom. Next. So your rocket runs and you get some output, data. Of course, now you're going to examine your simulation data and ensure you meet performance requirements. A lot of performance requirements are listed here. So your performance, we need to hit a max altitude. We need you to be within a certain static margin. We need you to meet a rail exit velocity. There's a thrust to weight ratio. So again, for the Mars teams, you should have all this listed and know what these requirements are. There's a requirements verification that the Mars teams do. So hopefully you've listed out all these performance parameters and you understand the values that your simulations need to return these at. For Moon teams, it's a little more work. It's the same requirements as Mars, but you don't need a requirements verification in your reports. But make sure you're satisfying requirements. You know what the performance requirements are. You need to look in the handbook. So flight simulations data, right? That's where you're going to get your results kind of in a line there. It shows the motor that you selected. I think it's K550 for this run, right? Gives you an optimal delay, gives you a bunch of parameters, and you can change the number of these parameters. I think there's like 10, but you can pick from 20 different parameters that you want to report out in this line. Of course, it's not the only way to get data out of RockSim. It's a quick way to look at things and say, hey, I reached my altitude. I didn't go supersonic, and I met the rail exit velocity, Next. Other ways to get data, there's a 2D flight profile. Again, this is on the full version. You may not get this if you have the trial versions. So make sure you download and purchase the full license version so you can use the full capabilities of RockSim. So it just shows you a visual of your flight profile, right? You get various data at all points in time. So it's like, hey, I want to know what my velocity is. I want to know what's going on at 3 seconds into my flight. I want to know what's my max acceleration or, my max velocity. At what point in the flight is that, right? This is a nice visual here to get that information. In the left image, to get to the 2D flight profiles, you just click the little icon with the curves there. Yeah, Rob's hovering over it. And there you go. Really, really powerful. And this also helps you determine if your parachutes deploy properly. So you can see at the top in the image on the right, there's a little blue, little triangle, little shape thingy there. That's your parachute. So you can be sure that the parachute deployed in the simulation. Sometimes it won't, and the representation will show that. Sometimes the rocket just turns around and starts heading back the other way, and you've crashed and no parachutes have came out. Next. Oh. It's the same thing here, some more flight data. So in the lower left, this is kind of the grid, right, for plotting. You can plot a bunch of data. RockSim has more data than you will ever need to, report out on. But again, these are useful for your reports if you want to show a thrust curve or you want to show your accelerations over time, velocity over time, anything over time, basically. And you can zoom in too. You don't need to see the whole flight profile if it's 90 seconds or 120 seconds, right? Maybe you just want to see the first 3 seconds of it. RockSim allows you to do that using the plotting function. Next. All right, finally, we'll wrap up with some common errors. So we're just going to list them here first, and then we'll talk about how to address them. So please ensure your vehicle mass override is off and do not use the vehicle level mass override. Ensure your CD, coefficient of drag override, is on and do not use. I've got a problem with these two being opposites of each other. I kind of wish they were both off or both on. Like you can switch the checkbox, but that's neither here nor there. Ensure all your drag is accounted for. So that's another thing we don't see. People are forgetting to put rail buttons or they're not considering their surface finish. That'll affect your final altitude, right? Ensure your parachutes are configured to deploy properly. So some people run simulations and they're not thinking about the parachutes deploying, which also affects the drift and the descent rates, all kinds of stuff with your parachutes deploying. Ensure your launch guide length is configured properly. So again, there's a rail that the simulations run off of. Unfortunately, the default's not set to anything realistic. So we'll show you how to change that to make sure you're running and getting the proper performance parameters out of your launch guide length or rail. And then ensure all your mass objects are accounted for. We kind of mentioned this a little earlier, adding each one of those little components. Next. All right, so ensuring your vehicle mass override is off and do not use. So say you have your rocket and you're adding components, you're putting a bigger parachute, you got a big motor, but every time you run, you notice that your altitude's not changing. You're getting the same altitude every time, no matter how much weight or components you put into this thing, probably because your mass override is on. So again, you'll go in the section there and you see it's highlighted, it says mass override, and you want to uncheck that box. So make sure that that box is unchecked. So basically what you're allowing, when you uncheck the box, what you're asking RockSim to do is, RockSim is now going to calculate the mass of every one of your single components. And it's going to sum all those masses together. And it's just going to do a weighted average to calculate the center of gravity of your rocket. And that's the correct way to do it. We want you to do it that way because you could do that manually, but it's much easier to let RockSim do the work. So you have to unclick that box. If you do click the box and it's on, what's going to happen is RockSim is going to assume that that mass shown on the screen is the final weight of the rocket. No matter how many changes you make, it's always going to use that weight that's in that box on the screen. So again, that's why we want to make sure it's off. Do not use it. Next. And conversely, make sure your CD override is on. So we want the check box to be on. We want the box to be checked. And again, by checking the box, you're allowing RockSim again to go and calculate the coefficient of drag of each of your components or the rocket altogether before each flight. So again, there's not really a way for you to know the coefficient of drag of your rocket unless you're doing wind tunnel tests. Even on your components, like you can calculate the coefficient of drag on a flat plate or a round object or a sphere. But putting all these components together, it changes, right? There's going to be surface drag and form drag that you're not accounting for. So let RockSim do the coefficient of drag calculations for you. Make sure to always check that box. Next. Some other common errors. So ensure all your drag is accounted for. So make sure you have rail buttons because your rail buttons produce drag and the drag affects your apogee altitude. So in version 10, what we do or what we've done in the past is you're kind of using a mock fin. You're using a fin jig or fin setup to create a fake rail button. So you can see starting from the left, we're adding a new component. We're going to add a fin. And then the bigger box there and kind of in the middle for fin object, we just create one. We want one fin, and we're going to make the fin like basically a little rectangle, like 1/2 inch by 1/2 inch by 1/2 inch, right? And what comes out on the end there, you see on the profile view of the rocket or the end on view, you see the little rectangle sticking out the side, right? So it kind of looks like a fin. You can imagine if we extended it out, right, it would be a fin. But now it's just a little button, kind of a little square sitting there, right? And what it is, it's the rail button. So the image on the very far right, that's what a rail button is. That's what kind of allows you to load your rocket on a launch rail. And it also produces drag in flight. So the size of that rail button is the size of that little rectangle there in your simulations. Next. And there's previous slide as well, just noting any protuberance should be modeled. So if you guys have camera shrouds or anything kind of sticking out into the airstream, if you got wires or some harness or something running down the outside of the rocket, try and model that in RockSim. You'll see it'll affect your altitude. And then you put in the airstream, it's going to affect your altitude. Another common error is your surface finish. So just making sure that your body tubes have the correct surface finish. So again, if you start out in the lower left image, you're going to click on a body tube. You're going to go edit. It's going to open the dialog box on the right. Notice this is the booster system, the booster tube, booster body tube. And again, if you click on again the right, the finish drop down, you can see it has unfinished, matte, gloss, and polished. You're probably not going to be polished. You might be unfinished, probably matte. So again, if you change for the any one of these parameters for all of your tubes, again, it's going to change the altitude in your simulations. If you want more altitude, you may think about, hey, how do we polish our rocket? How do we get a nice smooth finish so we get more altitude out of it? Maybe you don't want altitude. Maybe your motor's too powerful and you don't know how to slow down the rocket. Leave it as an unfinished, right? You want to produce that drag to not go as high.
And also to know if you're going to add weight for the paint you put on the rocket, just add that few ounces to the airframe, not mass to the one part of the rocket, because that mass is not there. It's through the whole airframe. Just add a couple ounces to that airframe. And if you're going to add weight for epoxy, probably going to be by the fins. So it's going to be by the actually by the motor tube. I know a lot of people like to do that, add the weight for the paint and the epoxy. So yeah.
All right, next. All right, ensure your parachutes are configured to deploy properly. So some people have problems figuring out, well, how do I get this parachute to work properly, right? So again, we're going to go prepare for launch, simulations, prepare for launch, as the left image shows. And then the right image, we're going to go to flight events, which is the second tab across the top. And then we're going to make sure that we have two parachutes. Like we mentioned in the previous slides, right? You always need a main and you need a drogue. And then each one of those, right? At the next drop down there, the last one on the far right, it shows you can select based on apogee, based on altitude, based on max delay. There's 4 other parameters that you can select your parachute events. The notes say your drogue parachute should be selected for deployed apogee, and your main parachute should be deployed altitude. So that's the only 2 events that you should be choosing. The other events are for other people or more advanced projects. For FNL purposes, always deploy your drogue at apogee and always deploy your main at an altitude. You get to input that altitude, and that altitude needs to meet requirements. So make sure you understand those requirements from the handbook. Next. Launch guide length, or the rail. And this affects your rail exit velocity. So your rail exit velocity needs to be 52 feet per second or faster. If you find in your simulations you're coming off at, say, 30 feet per second or whatever, anything slower than 50, go in and take a look at this rail. So again, you're going to go simulations, prepare for flight. You're going to move across the tabs at the top to the 4th tab. It says starting state. So when you open the starting state, it says launch guide length, I believe. You need it set to 72. I think default when you first download and install RockSim program, for some reason it sets to 36. And there's a typo there. It says never 32. Never 36. And unless you change that, the default's always going to be 36, which is a little rail like this big, right? And if you see the image there, the guy's standing, they're loading a rocket on the launch rail. That launch rail is like 10 feet high. It kind of depends on the size of your rocket, right? We do have 10-foot rails. Usually for heavier rockets, anything 20 pounds or heavier is going to be on the bigger rail. But 72 inch is kind of standard, having a 6-foot rail. You guys are in the probably 10-pound range, I think 15-pound range for your rockets. So you'll probably run on a 6-foot rail. So 72 inch in your simulations. Next. And then ensuring all your mass objects are accounted for, especially by CDR. So you can see if you think back, the rocket we downloaded, this is the rocket that's at CDR. So you see I've added another 20 or so components into this rocket. I may have increased the weight of this rocket by 20%, right? So now maybe my motor's not powerful enough to get me to 4,000 feet altitude, right? By adding these components. Yeah, so make sure you add a component for everything. Bolts, batteries, whatever's in your rocket. Shock cords, parachute protectors. Anything you guys put in there should be in the simulation. Next. That's all we got. That's all we got. I don't even know what time it is. How are we for time? Oh, perfect timing. Look at that. All right, any questions? That was a lot. That was a lot to take in. That was a lot to say.
And we know we didn't go into a demo with this The thought was this is going to be more of a self-guided walkthrough that you guys can use this PowerPoint to walk through as you guys are working in the RockSim. If you do need support, like if you're running into an issue with your file and for some reason it's just not working, we would suggest you set up a like requested office hours with me, and I'll pull in Frank, Mark, or whoever to help us diagnose what's going on and make sure your problems are resolved.
Just want to make a note when you go and look for a rocket in the library, inspect that rocket when you download it and make sure all the components are in the proper position. Sometimes they're not. Make sure that the owning parts are in the right positions. I've seen a couple that where the rocket did not perform as it should, particularly in recovery. So just be aware of that. It's one of the issues that I have while picking a rocket in the library. Also, we're going to be working mainly on RockSim 10. RockSim 11 is out. They have a few bugs in it, but they're working on it. One advantage to RockSim 11 is that it updates its motor database every time you turn it on. So there's probably less chance to go looking for a rocket at trustcurve.com, but don't count on it. But that's what they're saying. Also, there's a little handy chart that you can determine size of charges in your rocket. It calculates the size of your tube, how many square inches in your drogue or your main chute area, what type of shear pins they're going to be using, and it calculates how many grams you should use. But what you always do, what we tell you is test, test, test. Also, they have an enhanced 3D printed program for fins also that you can design and use in a 3D printer. There's a couple other more enhancements, but we're going to stick with RockSim 10, and this is what Mark was discussing. They did a fine job on it.
No questions, huh? You guys are all RockSim experts.
Right?
Your training is complete. You've all become Jedi masters.
So of course, if you have any issues, I'm not going to repeat what Rob said, but always ask.
Yeah, there's no silly questions to ever ask. So, but if you guys don't have any questions this evening, I will stop the recording. And 1, 2.